So the singleton is a design pattern and no one likes it, but it's going to be the thing that helps us out here. In this video, we're going to look at a refactoring technique to remove global constants. And this is something that I've used in a professional setting that seemed to work really well. We'll be starting with some usage of variables on a static class that are publicly available, and then moving towards a singleton pattern, and then from there being able to refactor towards dependency injection. We'll walk through this all in code so you can see how it's done. A quick reminder to check that pinned comment for a link to my free weekly software engineering newsletter. And before I dive into the code, I just wanted to talk through some concepts first, and then hopefully the technique and the code we're looking at will make a little bit more sense. So when I talk about globally accessible variables and having these on static classes so that anyone in a program can access them, I want to talk about why this is a little bit dangerous. The first part is more philosophical, and it's that the different parts of your system, there's no real control or guidance over who's able to see what. There's no enforcement of responsibilities, and because it's something that's global, everyone can see it. And on the surface, that's not necessarily such a bad thing. It's just that it's a little bit weird to not be able to have constraints or control when you're implementing parts of your system. And if things were just read-only on those globally accessible variables, really that's not so bad. But it gets a little bit more dangerous when we start talking about mutability. When we're talking about static variables, these are shared state. It's one particular piece of state that we have for that variable for the context of your entire application. So if it's not constant or it's not able to be fixed in place and it can change, this means that you have different parts of your application that can be reading this information, and at different points in time it could be changing without them totally knowing or having control over why that's happening. There might be situations where if you have global accessible state, that state could be changing behind the scenes due to something external, or you might have different parts of your application that could be mutating that state. And if you're doing things out of order, that's where things can get pretty weird because there's no real control or enforcement. And if anyone in the entire application can touch and modify the state of that variable, all of the other parts that are consuming it are at risk of having that change under their feet. So consider how complex this can get if you have asynchronous code that's running, or consider if you have hundreds or thousands of tests in your test suite and you have something like this executing out of order. All of a sudden your tests start breaking and you run them again and they start passing, and the flakiness and having to debug tests like that is an absolute nightmare. So what about the singleton? How is that going to help us here? So the singleton is a design pattern and no one likes it, but it's going to be the thing that helps us out here. The whole point of a singleton design pattern is that it ensures exactly one instance of something can be created. And the other part that seems to go hand in hand with it, but it's not necessarily a requirement of a singleton, is that singletons are generally globally accessible. Again, it's not a requirement. It just so happens that when people implement them, they're often done this way. So now you might be asking yourself, okay, if a singleton is one state and is globally accessible, is this not the exact same problem? And the answer is kinda, sorta. Like, you're onto something here, right? They are very, very similar. I'm not going to try and deny that. But I like using a singleton in this case as a stepping stone to be able to refactor code over time. So by moving to the singleton, we're able to program against an API. And then from there, in my opinion, we can kind of stop, like what I would call stop the bleeding, so that people stop using that global shared state in the static class. We can move away from that and start programming against this interface. And I think this is a good opportunity for us to jump over to Visual Studio and start seeing how this works in practice. On my screen, I have a sample program that is going to be using this static globals class that I have here, and you can see that it has 3 public static variables on it. And at the very top, we have this tiny little program that we're going to walk through, because this program is going to leverage this class with these global static variables. So the first part that I want to talk through is checking to see where this is used, because our whole goal here is to try and get rid of as much of this as possible. I'm also going to call out that I did try to make this example simple, so you might be reading this code and saying, well, if you just want to make these things all read-only, doesn't most of the problem go away? And you're absolutely right. This is a contrived example, so this could be a lot more complicated in real life than just being able to mark these things as read-only. So the goal here is really that I have a sample application, and we're going to try and get rid of as much of this as we can. So if I scroll a little bit lower in the code, we have a class that's called myAPIClient. And if we look at the code that's used inside of this method called fetch metadata async, we can see that we have the global statics accessible right here on lines 57 and 58. What we're going to be doing is adding an API key and a username into the headers on this HTTP client. From there, we use the client to go fetch some data from a website. A quick reminder that as I'm going through this stuff, what the code is doing is not necessarily important. It's really more about how we're using these globals and how we can move away from that. So this is one spot where it's used, and I wanted to include in this exercise another class that we're not going to be very interested in. It's not really part of the core workflow that we might be focused on, but it's also using these globals. And I wanted to introduce this because I didn't want to trivialize the refactoring process. I wanted to show you that if you're trying to do this in real life and you have some other code that's also using the globals, you could find a way to chip away at this over time. If I jump back up to the globals, you can see that I had this extra public field as well. I want to include this in the example because what we're going to see is that we can't get rid of this whole thing, because I wanted to have a field that it's not currently used in the code that we're looking at, but it might be used somewhere else in this bigger application. So our goal is to get rid of these two things, and at the end we should be left with just this one because we can't tackle it quite yet. It might be buried somewhere else in the code base, and for what we're looking at, we're not able to touch it right at this point. So we were able to see the usages of these username and API key fields on this globals class. And the next step that we want to look at is trying to see if we can pair this information out into an interface. This is an opportunity for us to use some creativity, so instead of just moving to a singleton that's going to be called globals or something that's very, very generic, we could try to make this more purpose-built. And the goal of this, like I said, is that we're going to be programming against an API. So let's come up with something that makes sense for these fields being used. I'm going to go ahead and create an interface called iAPIClientConfig, and it's going to have these two properties that map to the two fields that we have up here. This is going to be the interface that we have for our singleton. If you're trying to minimize the amount of refactoring work, having these things paired up to be almost the exact same is very helpful. It'll make the process a little bit easier to go through, but you don't want to trivialize it either. So if you're making more work for yourself down the road, I think this is a good opportunity to come up with different names or just come up with the right feeling for the API that you want to be coding against. From here, we're going to create our singleton. I've gone ahead and created the singleton implementation, so I'm going to explain how this works in a little bit more detail. The first thing to call out is that I'm going to be using the lazy pattern for creating an instance. And what's really nice about the lazy pattern is that this is going to enforce thread safety, and truly this only executes only once. So by leveraging lazy, we can get a lot of the work done for our singleton. Now, what is the lazy implementation creating? Well, it's going to make this API client config that I have down here. So let's talk about that next. This API client config implements the iAPI client config interface that we just looked at. You can see that I've marked it as private, so no one else outside of this class is possibly able to create this. And the other thing that we're doing, if you look at the implementation of these two properties, is we're directly referencing the globals. In my opinion, this is an optional thing that you can do. I like doing this because in the meantime, if you have a big refactoring going on, what you're doing is making this almost identical to the current behavior. If we're just referencing this, then someone else being able to reference this username property is essentially just getting a pass-through to the globals. That means if you had weird behavior with state changing out of order, it's going to be identical as you're going through this refactoring because this is just a pass-through. However, you could also take this opportunity to instead go make this not touch globals at all and hard code the things that you want to use here, or put in the implementations that you need to. The way that I've seen success with this in the past personally is that if I start moving all of the global access behind a singleton interface, the only spot that's going to be left in the application touching globals is inside of these singletons. And for me, that's a really nice way to have a clear indicator that I'm able to take the next step, which we'll talk about in a little bit. So now that we have our singleton implementation, we can go start replacing where the globals implementation is used. The first spot that we had is in this my API client implementation. So I can go ahead and say API client singleton.instance. And I'm going to put that all on one new line so it's more readable. I'll do the same thing for the field that was used right below. So now we have the two singleton usages right here replacing the globals usage. And we had one more spot that we can do this, and I'll go do that same change here. And now we have both usages replaced in the two classes. And now you might be saying, well, Nick, this is literally the exact same thing. What was the entire point of doing this? And I want to remind you that this is my pattern when you have a large refactoring going on in a big code base. If you had something truly as trivial as this, going to a singleton might be just a whole extra step that you don't really care about. But if you weren't able to go replace all of the usages of the username and API client, and you might have to leave those intact for a couple of different commits, or possibly weeks or months, if you need to do this incrementally, I feel like this singleton approach gives you that flexibility. And a lot of what I try to talk about on my channel is giving you real world advice, not just theoretical stuff. Because yes, we could go just jump to dependency injection right from the start of looking at this example. But I want to walk you through some tools that you can use, hopefully in real life, in complex scenarios. And if we don't talk about these as potentially being more complex, you might be thinking about this video, if I had simplified it a great deal, and going, well, Nick said to do this, but that's not even going to be applicable here. We'd have to go try and make changes to 1,000 files before we could even commit this. And that's going to be nonsense in real life. You can't get away with trying to block changes on huge refactors for weeks or months or anything like that. You need to find ways to do it incrementally. So the entire goal here is that now we can start programming against interfaces in the spots that we were using the globals. As long as we were able to safely go touch these things, we can start putting the singleton usage in place, because it truly is, the way I've done it here, a direct replacement. It's in fact referencing the globals as a pass-through. Fundamentally, all that's really changed is that the calling locations are now asking an interface for the data versus going right to the static class. And that's because static classes just cannot have interfaces in C#. So let's go back to the code and look at the next step for refactoring this. Now that we have this code in place, it's going to be working against an interface, which is IAPI client config. We can start to do some interesting things with our dependencies. So if we think about this code that's on the screen right now, it doesn't really care that it's getting the implementation of the IAPI client config off of this singleton. All that it really cares about is that it needs that dependency. So let's provide it in a better way. Let's provide it through the constructor so we can work towards composition. Now, in some cases, the code that I have on screen right now with this new field API client config being instantiated by just accessing the singleton in the constructor and then leverage down here, this might be the only thing you can do in the start. And the reason I'm saying that is because the ideal situation is that we want to start passing it in through the constructor. Once we can start doing this and passing it in through the constructor and having it assigned here, this means that we can start feeding it from higher levels in the application. So this would be more ideal as the next step, but you might find that all of the spots that you're making an API client, you're unable to start passing this in. As soon as you start making a change like this, you're going to be in a situation where you're doing more refactoring to go now fix all of the spots that call this. But truly, this would be the next step that we want to get to. However, you might be able to do something like this in the interim to get you one step further. You'll notice that the number of times that I'm calling the singleton instance, instead of it being 2 down here, it's only 1. So this is a very small step forward, but it's still a beneficial step to take. In our case, we're going to go all of the way and pass it in through the constructor. I want you to keep in mind that we have this other location that needs to be patched up as well, but I'm going to leave that to a little bit later so I can demonstrate to you what happens when you run into a situation where you don't have all of the spots replaced. All right, so now we have our API client being instantiated this way, but the reality is there's a calling spot that's creating this, and it's not currently passing in this config. That's because we just added it as a new parameter. So if we go into this class called myBusinessLogic, which we haven't looked at yet, we can see that we're creating an API client right inside of the constructor here. But the problem is that we're not passing in the config here. So where does that config come from? It comes right from the singleton. All that we're doing is slowly moving this problem of using the singleton further and further up the call stack. And I'm showing you this in incremental steps because at each one of these line changes that we're making, in my opinion, that's a net beneficial step forward. Because if I jump back into this class now, my API client, we can see that this class doesn't use the singleton at all now. We've fully removed dependency on that global's implementation here and from the singleton. You can see how short-lived the singleton was in this particular case, but depending on how complex your application is, it might be a little bit longer lived. In the myBusinessLogic class, we're encountering the same sort of issue though. So what's the next step? Well, we just repeat exactly what we did. You could go ahead and pass this in just like this, or if we're looking at this code as it currently stands, I might say, well, why is myBusinessLogic responsible for creating my API client? In fact, maybe I want to go push this whole thing back up to be passed in. So this is an opportunity for you to make changes like that. If you just want to continue passing in API client config because it's one tiny little step better, in my opinion, that's totally fine. But I think we can do better in this particular case, and we can just pass in the whole API client. But when we do this, like I said, we just move the problem further up the call stack. But that's pretty awesome because further up the call stack is right at the very top of our application. And that means that we need to pass in an API client, and in order to make one, come on, Copilot, you should be able to figure this out. It's going to make me type the whole thing. We're now able to do something like this. Let's close Copilot. You could have done that. I know you could have. We're able to have this, and now the singleton is only used at the very top of our application. The goal of doing this is that we want to move all of our dependencies to be passed in via constructors, and then at the top level of our application, that's where we're creating them, because there's an awesome pattern that we can use once that's in place. So we're almost at the point where we can even remove this singleton, but I did mention that I was leaving one more spot that's going to foil our plans for now. And that's because this other class that we had at the very bottom here, this one is still using the singleton instance. And I mentioned that I brought this in, not because it's being used in our code currently, but to demonstrate that this might be somewhere else in your code base and you can't get rid of the singleton instance yet. And that's okay, because at this point in time, we've gone and refactored some other things. If I scroll back up a little bit to this API client, this one we could go write unit tests for and not have to worry about them being interfered with by the static class, maybe someone mutating things or anything like that. This one is entirely isolated and awesome to work with. This one here still runs the risk that if someone could change any of these fields, we could be in for some issues. So the next step, if we could, and we're going to demonstrate that we can, is that we want to go do the same exact thing with this class. Again, I'm just showing you that you can do this in increments, and as you do it in increments, you're making the code net better at every step. If we were able to, we could do this exact type of refactoring that we saw earlier, where we start passing in the client config through the constructor, and the calling locations that we're touching the singleton no longer reference it. Just keep in mind that as you start doing this and changing the constructor, you have to go up the call stack and start modifying all the other locations. And because currently in our code nothing else is using this, we can go ahead and take that next step. So all the way back up at the top, if I go check all of the usages of the instance property that we have for our singleton, it's only this one spot at the very top of our application. This one line that we have is truly the only spot. So we can take the next step to totally kill off the singleton. Now, in order to do that, there's something cool that I did in the implementation here, and that is that I made an implementation of the config that we want right inside. So I'm going to go ahead and cut this out, and then I can go ahead and delete this singleton. It's now completely gone from our application, and that means this line up here is going to be complaining. If I paste this config back in and make this public instead, we are even closer to being done. At the very top here on line 1, I can replace that singleton with creating an API client config, and that's going to new up an instance of this class here that we just dropped in, and we can pass it right in on line 2. At this point, our singleton is completely gone, but we haven't gotten rid of the globals part. But that's totally cool because this part's super easy to do now. I can go replace this username up here with the right username. I can go move the API key right up to here. And now these two globals, these fields on here, we don't need them anymore. I also realized that I should have left a comment in here, not that it's important, but you should never do this. There we go. There's some redemption. Don't ever do this kind of thing. You want to use other techniques to pass in this secret information. So just keep that in mind. So in our application now, we've effectively gone from having these two other global fields on here through a singleton to be able to slowly chip away at refactoring. And once we've gotten through all of that, we're now done with the usage of that singleton. We can't quite get rid of this globals because I left in this field that I mentioned at the beginning of this video that we're going to pretend this is used by some other parts of the code. But what you would do is repeat this exact process we looked at in order to start chipping away at whatever's left inside of globals. You want to get to a point, if at all possible, where you can start passing things in through the constructor. And I want to round out this video because if you go to implement this type of thing in your production code, and your code base is a lot bigger than this simple example that I was just showing you, what you're going to find is that you start having hundreds or potentially thousands of lines of initialization code right at the top of your program. And it's cool because the rest of your code became more testable. It's using composition and interfaces, and that's all really nice. But the entry point to your application is now a complete dumpster fire. If you have hundreds or thousands of lines of just newing up classes and stuff like that, it's nearly impossible to navigate. But the solution to this, in my opinion, is using a dependency injection framework. We can start to organize our different initialization code into different modules, organize things more clearly, and have a better understanding of what's going on. Instead of trying to scan hundreds or thousands of lines that are stacked together to go see where something's created, we have dedicated modules or classes that can do that for us. I'm going to go change this code. We're going to use AutoFact to do it, but because I'm not using ASP.NET Core, I'm not going to be showing you the Microsoft dependency injection framework. It's done in almost the exact same way. It's just that the syntax is different. So you can go ahead and apply the same exact concepts that I'm going to show you with AutoFact and use that with the Microsoft built-in dependency injection framework. What we want to be able to do is have these different things that are our dependencies created almost automatically through AutoFact or a dependency injection framework. In AutoFact, that's done through something called a container builder. In AutoFact, the way that we can start to organize our dependencies and have them registered to our dependency container is using something called a module. And to do that, we override the load method that takes in the container builder, and we can start to do our registrations inside here. The three things that I want to be registering are these three classes right here from lines 5 to 7. The first one that I'm going to do is the API client config class. I'm going to register that type on the AutoFact container, and then I'm going to say that when people want to resolve it, they can only resolve it by the interfaces and not by the type itself. The other thing that's really important and really relevant if you think about all of the usage of this config that we had before is that it's going to be single instance here. Does that sound familiar? It's not going to be a global constant. It's not going to be a singleton implementation through the design pattern. But we're using dependency injection to say that anytime someone asks for an API client config, they will always get one instance that's created. See, there's different ways that we can get a singleton. Registering the API client is going to be similar. In this case, I'm not going to be doing it by the interfaces, and that's because when I was refactoring this code, the dependent spot, my business logic, requires my API client class. I could have extracted an interface and then used that here, but we're not going that far in this refactoring. And the other thing to call out is that in the current implementation, I can get away with single instance. That's what I would expect here. However, in different cases, you might be saying, well, that's not going to work because it's not thread safe, or I need to make sure that there's different usages of this because I can't share the state in different spots. That's for you to decide and figure out, but I'm just explaining why this part looks different than this part right here. And finally, the last spot that I'm going to do is add the same thing in here for my business logic. It's going to look the exact same as this pattern for the exact same reasons. We never end up resolving an interface called my business logic. It doesn't exist. But if we look back up here on line 7, we can see that we're using that directly here and on line 8 directly as the class. So now that we have our module, we need to register that to the container. This is a pattern that you can use for this, and I have other videos which I'll link right up here, and you can watch that now on different registration patterns to go scanning for assemblies. Once we've registered the module or the other modules that we need, we can go get a container. Copilot's so awesome, I barely have to code anything anymore. The next part after we have the container, as Copilot's suggesting, is that we want a lifetime scope. I'll just press tab and let it finish this entire video for me. Yep, Copilot's right again. We want to be able to resolve my business logic off of this scope, and all that we're going to do is the exact same thing where we're getting that result and again writing that result to the console. And that means that I can go ahead and highlight this code and delete it. We now have dependency injection done for us right up here. All of that handles getting this module registered, and in your application you might have a bunch of different modules. You can go organize those by feature or however else you see fit. If I go back up, once we have these modules registered, the only other things you need to do are build the container, get a lifetime scope, and then resolve the first part that you want to enter to in your application. And that is how we get dependency injection to work, starting with these static global variables that are potentially really dangerous in our application. Remember that when you have stuff like that, other people can potentially mutate them, or those things might be changing behind the scenes, and all of the different spots that use those static globals could be at risk of having that stuff changed under their feet. From there, we went to a singleton design pattern, and for a lot of people, the singleton makes them wildly uncomfortable, and that's because it's almost the exact same as having these global statics. I get it. Every time I see a singleton in code, I get goosebumps all over my body. I want to get it out of there. But I just showed you that I have a use for it, and I have used this professionally in very big code bases where we had tons of these global statics. This is literally a pattern that I have picked up from my professional experience and just applied to this really simple example. Once we have the singleton in place, we go back through our call stack, trying to get rid of the singleton wherever we can. And this allows you to incrementally refactor by composing your objects of the dependency instead of just directly accessing the singleton itself. And finally, once you're in a position where you can get rid of all of those singleton references, you can go over to something like dependency injection, because all of your dependencies are able to be passed in through the constructor. I used AutoFac in this example, but you can use the Microsoft one or any other implementation of the dependency injection framework that you'd like to work with. If you found this video useful, I'm not going to link you to another one, but I do have a course on Dome Train that's about refactoring. It's about 5 hours long, and it has all sorts of examples of different techniques to walk through for you to refactor things. I'd highly recommend you check that out if you found this useful, because this particular example is not in that course, but I think there's a lot of other useful examples that you can leverage in your own practical experience. I'll have that course linked in the comments below as well, so if you're interested, you can go check that out on Dome Train. Thanks so much for watching, and I'll see you next time.